So I'm sure you've heard a lot about containers and microservices in Docker. A little digging and you quickly find out it's almost all CLI, or otherwise command line interface, which for some can be super intimidating. You might say, I'm just fine writing C++ or C# and going about my day deploying to IIS or whatever platform you're currently deploying to. Containers, obviously, I'm going to have to learn Linux, and I'm going to have to learn a bunch of CLI command line. I'm going to have to learn bash scripts. It's intimidating. I don't use that platform. I point and click in Windows, and I get by just fine. I'm a developer. That's what I do. Maybe you're just strictly C#. So containers might seem kind of off-putting. I'm not going to try and pull one over on you. Linux is inevitably something you're going to want to learn as a byproduct of working with containers. But what you'll find is the use cases are just as interesting and fun when you get into containers once you get started down the container path, and you'd be surprised just how many ways you can employ containers in your daily work, from spinning up a service that you need to deploying your entire application, or maybe you're making a game or running a service or server for a mobile application. So super interesting ways you can use containers. To give you a quick background, here at TaxSlayer I've authored roughly a dozen microservices that are containerized or at a minimum poised to be containerized. And what do I mean by that? Using languages like Golang and .NET Core, we're able to deploy both to Windows and Linux. So this allows certain applications to be containerized while others can remain in Windows legacy IIS environments until the rest of the supporting apps catch up, which at some point can flip a switch and then they can be containerized as well, and server management systems like Kubernetes clusters can manage the services and bring them all together. If you're watching this and you work at TaxSlayer, you by now have heard the buzz in the hall, or maybe have seen other developers working on containers. The applications really are amazing. They're easy to deploy. The whole CI/CD pipeline's easier to maintain, and it goes far beyond just what we do at TaxSlayer on what you can do with containers. So here's a look at my desktop, and right now we're looking at my NAS container, and it's running a Minecraft server, and it's a single instance. Notice as I join and leave the server, you can see the actions occurring in the container log. We get real-time feedback in the logs. We also can see the load that is causing on the CPU and memory as users join and leave the server. So you can kind of decide maybe we need to ramp up more containers because we're getting more people on the game. Maybe we don't need as much servers available. We can decrease our costs by decreasing the containers we're scaling out to. It gives us that type of flexibility. Now, while the graphics and stuff are rendered locally on each user's client, the actual blocks and all the states of how the Minecraft instance is running are all held and passed to every single client from that container running on this server. And it doesn't take a lot of CPU or RAM to do. You can see the CPU's roughly idling around 15%, RAM 13%, and it's running multiple clients connected to it. So that's an interesting platform right there. And then to kind of take it a little bit deeper, I've actually been working on an open source AAA title, Final Fantasy by Square Enix, and this is a server engine that's running, and the server engine itself was written in C++ and is designed to run in Windows. What I've done is I've compiled it for Linux and containerized it. I also broke it into 3 separate segments so we can easily distribute the load. And if you see here, I've got this character Kitty attacking a boss, and every single time I perform an action in the game, you can see the action occurring inside the logs for that game. And so you can easily see that what the players are out there doing, the containers are actively servicing those requests. And if we see that, hey, our servers are getting loaded down, we've got a lot of players that are playing right now, you can just scale those servers up, scale those services out, and support that demand. And this specific design, I'll go ahead and show you. Let me just kind of warp over to town, and I'll show you how we actually talk to other containers. So let me pull up that container, it's the auction house container, and you can see here, now I'm talking to both a game container to track where my character is going and what they're seeing, and I'm also talking to an auction container to see what's available in the auction. And so now this gives us the leverage that, like if we go into the TaxSlayer world, maybe we don't need to ramp up the web containers because the website servicing requests is just fine, but the calcs are just getting really loaded down. So we need to ramp up the containers around the calcs, but not necessarily ramp up the containers around the web services themselves, the website. So it gives you that level of flexibility when you break up a monolithic or a large application into these little microservices or micro parts. And in the game you saw, I simply specify which ports need to be exposed. I can optionally load balance those, like I mentioned, using services if I went the Kubernetes route or Docker Swarm, and then you just tag which containers are part of which services, so this way all the load gets distributed to similarly tagged service or containers for that given service. So kind of going over, I'm going to pull up the slide here, the basics of the Docker system. So like in the game example, I've got a Docker file that points to a GitHub repo, and that repo has source code that needs to be compiled. So what I do is I execute a Docker build on my host machine, and that's my computer that I'm on right now, and it builds the container A, like in this example here. Now, in my specific example, I actually have 3 containers it builds, but you'll get the idea with the diagram here. So then what I'll do is I'll push that container to the container registry, which I use Docker Hub. It's free, public. You guys can use it too. And you can have public and private repositories out there. And so I push it over to that container registry, and now my container is available for me to pull down with any cloud solution. And so at that point, in this example, host 2 OS is Google Cloud, and then I pull my containers down, or my actual images down into Google Cloud, and I containerize them there, and I can materialize as many instances of that container as I want, and that's kind of how that whole Docker system works. And I know a lot of people ask, what's the big difference between Docker and VMs? It sounds a lot of the same thing, just a different name, but there's a pretty significant difference. So TaxSlayer probably has hundreds of VMs currently. Countless of them are running IIS and load balanced, and maybe even those load balancers might be VMs themselves or appliances. But what the key difference we see here are the physical hardware that the hosts that service these, if you will, require way more resources in the VM world versus the container world. In the VM world, you have to load an entire OS up and then load drivers into that OS to support the underlying virtual hardware. With the Docker system, you don't have all that extra fat that the guest OS puts in, and you just have a thin layer of the guest OS, and that guest OS is just enough to tell the underlying app how to kind of function. And so you still can have a Windows container and a Linux container, but it just doesn't have all that bloat that the whole entire OS running would have, and so it gives you some latitude there. And kind of bringing this home, hopefully you can see just how beneficial containers can be for you. When you're doing your day-to-day work, you're writing software and you need a SQL server, what do? You sit there and you install Microsoft SQL, and you click all these options, and you choose all these different things, and where do you want the data stored, and what do you want the instance to be called, and do you want Windows authentication or not, and you choose all this stuff, and then it says, oh, but I got to reboot. With Docker, I can spin up a Microsoft SQL server in just one single command line, and it's up in seconds, and then I can destroy it just as quickly. So to have that ease and flexibility while you're developing makes developing software so much easier, faster. You instantly can spin up a Mongo server, or if you need a Redis cache or whatever you're trying to develop to, you can just spin it up in seconds and it's available for your application to talk to. So that type of flexibility is just right at your hands. So I highly recommend you just download and try Docker and start playing with containers and see where you can go. Thanks for watching. Look forward to hopefully making some more videos.